Yeah, hello everyone. I first thank the organizers for the kind invitation. So myself, I am Siddartha. I did my PhD from Indian Institute of Science, Bangalore. Most of my research is focused on developing machine learning algorithms for graph structured data and higher order data. So today I will be talking on AI for healthcare. So the title of the talk is AI for Healthcare, Challenges and Future Directions. In particular, I will be talking or giving the flavor of graph neural networks for this AI for healthcare applications. So let's go into the talk. Following is the agenda for this talk. We start with the why there is a buzz around the AI. Then we'll talk about why deep learning is needed for healthcare applications. Then we'll ask the question of why AI for healthcare again. Then I'll talk about what are the recent advances in AI for the healthcare applications. We'll end the talk with the future directions and challenges, where I will be talking about the state of the art methods right now, and I will talk about the challenges involved in AI for developing the healthcare applications. So these are the five or six agenda topics for my talk of 10 or 15 minutes right now. So we ask the first question, why there is a buzz around AI? So, to be precise, from last one decade, there is a lot of buzz around AI. I think the reason for that is because the computational power of the devices grown exponentially during the last decade because of all the CPUs and everything. So, and deep learning has taken off from there. So, what is the deep learning about? So, for me, a simple answer is deep learning is all about training the machines to mimic the human brain. So consider the following image at the left. It's the brain of a human, and you have a lot of neurons in this. And imagine for time being, this is the brain of a very small kid for time being. And so you want to train the small kid. So what will we do? So we'll show him n number of such images, dogs, cats, and everything. And every time we tell him that this is the image of the dog and this is the image of the cat until he remembers or he tries to learn the features of the images, right? A dog or a cat. So once he learns these features, very next moment, after 4 months or 5 months of the time, whenever he sees the dog, he always recognizes the image of that is the image of the dog or the image of the cat. What is happening there? The kids are the small kids, they are trying to remember the features of the images you have shown him the way back. So during this process, neurons in the brain, they have learned something. So that process of learning the features in the images. Similarly, we want to mimic the action that I have helped here to machines. But how do the machines do that? Machines also want to learn that or want to learn what brains are doing, and to do so, we have a lot of neurons and you stack them as a layers and you show them n number of such examples. And every time you tell the machine, this is the image of the dog and this is the image of the cat until it learns. So here, learning is a process. And once it learns, whenever you show the machine a new image of similar features, let's say the dog features, then the image of the dog should be recognized by the machine. This is what deep learning models are trying to do. For that, they're trying to learn the features of the images you have asked it to learn. There are different process of making it to learn, but this is not the talk of about how learning happens and all this stuff. But it's the simple agenda of deep learning is it want to mimic how human brains work. Then the very next question, then what is deep learning for healthcare means? So now just go back to the above before slides. So there the image at the task at hand is image recognition task, right? It's we are categorizing it into a cat or a dog. But when it comes to healthcare, whenever the machine learning models, if they cater the healthcare applications for time being like tumor recognition here, we call it as AI for healthcare. So for that, you have a deep learning model and you have an images. For time being here, you train the model with two sets of images, one with tumor and one without tumor. And you ask the model to learn the features in both the images, one with tumor and one without the tumor. And whenever the new image. For time being, the MRI image of an individual comes, for instance, with the features of a tumor. Then the machine learning model, then itself, it should recognize so and so person has the tumor because of following set of features in the MRI image. So this kind of learning happens when you do it progressively with the all kinds of training samples you have, tumor and non-tumor, different types of tumors and everything. So the main agenda of AI for healthcare is you are training the deep learning model to cater healthcare applications like tumor detection. Now other one more application is arrhythmia identification. Arrhythmia is it's again a disorder where you have an irregular heartbeats. So what do you have here? You have a machine learning model again. You have both the sets of and normal heartbeat samples and the samples with arrhythmia. Then you are asking the deep learning model to extract the features of both of them, and you memorize the features of both normal individual and the patient with an arrhythmia. So whenever for the next time I show you an ECG model or ECG data, you extract the features of the data and you map that with the learned features of both arrhythmia and non-arrhythmia, and give me a solution whether the patient has an arrhythmia or not. So this is how, like, tracing back, it's all about you are catering the deep learning model for healthcare application. So these are two examples where I helped you to understand the deep learning model can be used for diagnostics applications like tumor identification or arrhythmia identification. But you can always use the deep learning module or the AI for different healthcare applications, and that I will show you in the next slide. Like here, sorry, like here. So AI in healthcare can be used for different purposes, like I explained you in diagnostics, in drug discovery, the problem which we'll discuss in the later slides, in surgical arm detection, and many more applications. But you should ask me a question: why do we really need AI for healthcare? For me, following three points helps or make sense. So for that, first point is you can always have a improved decision making with very less latency, meaning that you can have very fast decisions without human intervention, and you can always optimize the resources, and you can always reduce the costs because you are not spending it for the personalized or any specialized individual, because machine is taking over to detect whether a person is having, once it has an ECG data, it is just telling you whether you have a tumor or a arrhythmia in it. And more importantly, a remote and underprivileged gets the world-class diagnostic service, because all you need is just a ChatGPT like model, and you what you need is just a ECG data of the individual, which can be captured these days very easily. So following three points helps says that AI is really needed for healthcare applications. Then now switching on the gears, now I'll talk about what are the advances in AI for drug repurposing task. To start with, we'll first discuss what drug repurposing is. So, drug repurposing, it's a paradigm where you have existing drugs and you want to use the existing drugs to the unseen diseases. What are the unseen diseases for now? Let's say in 2020 or somewhere around that time, we have COVID, right? At that point of time, COVID doesn't have any vaccination. But what people are trying to do is you have set of vaccines available that treats different diseases. Now I want to use all this set of drugs to treat COVID vaccine. So dr- set of available drugs are there for new old diseases, but not for COVID. But how can I use them for treating the COVID? That is what drug repurposing means, to use the existing drugs for new disease. So for that, people has come up with the different artificial intelligence models, but like deep learning models. But recent trends are towards exploiting the structure in the data. So for a drug repurposing task, so structuring the data, I will explain you what are the different structures, how can I explain the exploit them in particular, and what are the different neural network architectures to use to learn the representations of these structures. To start with, since I'm more a GNN guy, a graph neural network guy, I'll use that GNN example to for a drug repurposing task. So I guess the idea is very clear. Here we have existing drugs, but I want to treat the very new disease. So we start with the graph neural networks. What graph neural networks? So graph neural networks really took off in 2020, from 2020, because that's where the people started using these convolutional neural networks supported on graph data. So then when COVID really hit in 2020, people tried out using graph neural networks for drug repurposing task, and it really worked very well at that point of time compared to conventional neural networks. So what is the idea? So here the idea was, you want to exploit the relation, because you have drugs, you have diseases. Drugs treats the diseases, and each of these drugs will hit some of the has some of the protein structures associated with it. So here I want to associate, or I want to interlink the drugs and disease relation to to develop a new drug for the new disease. So for that, people use something called graphs. What are graphs? Graphs are the mathematical tools, just like any mathematical tool. It's a function that models the relationship between the nodes. So for time being, just imagine you are a class of 100 students, and each of these 100 students, you can consider them as nodes of the graph, and we can model the relationship between the students using something called edge. So with that type of modeling, we already have a structure in the data, because all the 100 students of you might not have the friendship with all the other 100 students, right? Only few of them has few of the friendship links. So I want to relate that for drug repurposing task. Then what does that mean? So and so drug treats so and so disease. Like only few of you might be friends with few of others, right? So, like you cannot have the friendship with all the 100 guys in the class. So like that, only few drugs treats few diseases. So to exploit that, people use something called graphs. So an analogy of that can be done here, like I explained you in the student network or in the friendship network data. Like what are the nodes in the friendship network data? There, the nodes are the students, right? And what are the edges there? Whether they have the friendship, if there is a friendship between two students, we have the link between them encoded through edge. But for drug repurposing task, we have the nodes as drugs. And what are the edges? The edges are whether the particular drug is treating the disease or not. So for time being, aspirin treats headache, muscle pain, and all this stuff, and the aspirin interacts with so and so protein. So like that, you encode the relationship I have shown here, where you have a drug network where drugs interact with each other, and you have a disease network where so and so diseases are interrelated, and you have a gene network that encodes the relationship between the proteins. So once you have these, and even there is cross interactions, like drug can treat so and so disease, even the drug will can interact with the protein. So everything is captured in something called graphs. So now people started using this and the embeddings of this to learn the representations of the nodes. So how do we do that? So graph neural networks gives the solution for that. So as I explained you, graph neural networks, these are again deep learning architectures. What they do that is they learn the representations of the nodes of the data. What are the nodes here? Nodes are either drugs, or diseases, or the proteins. Then how do graph neural networks learn the representations? Graph neural networks learns the representations using something called message passing. So what is message passing here? So if you see here, there are these emails that are circulating between the neighboring nodes, right? So what message passing algorithm tries to do is, it starts with a node. It sees what are the messages across the neighbors of this particular node. Then it computes the embedding using the self embedding of that node and the embeddings of the neighboring nodes to find the representations of that. So in particular, once you do message passing of that over this network, what you get is representations. So like I shown you in this oval shape, these are the representations of the nodes. So once you have the representations of these nodes, you can use these representations to see whether these nodes are alike or not. So out of six nodes or seven nodes here, once you have the representation, we say that five nodes are four of them are behaving something similar, and the rest two of them are some arbitrary, and they don't have relation with the other two nodes, and two are behaving similar together. So you can see the clusters of nodes, right? What are alike and what are not alike. So the representations are used for that. Like you can use representations for classification, or you can use it for predicting the links, like we do it for the drug repurposing task. I'll show it in the later slides. So now, how do we use graph neural networks? So just recall, I'll go very slow here. First point was we constructed the graph. How do we construct the graph? The analogy was something similar to student friendship network. So here the analogy was you have nodes as drugs, proteins, and diseases, and there is an interaction between drugs and diseases. So we can always construct the graph using that. And the second point was you want to learn the representation. How are we doing that? We are doing that using message passing neural network. What is message passing neural network? It finds the embeddings of each of these nodes in the graphs. Once you have the embeddings of these nodes, whenever the new disease like COVID comes, so this the structured data is available for the existing network, existing diseases, existing drugs, and existing proteins. But the new disease comes like COVID. I want to find the mapping of the COVID that is a disease. So I put the node in the disease network. Now I see how do I learn the representation? How do I find the new drug? I want to find the embedding of this particular disease, and by mapping it, how close it to the other drugs or other proteins. So once it is very close to the other drugs, meaning that it treats so and so, it is treated by so and so drug, or it is treated by so and so protein. So I find the mapping of this particular disease, new disease, to the existing embeddings already available from the data. So that is how drug repurposing happens. So three steps are: first you do graph, second you find the representations, third you find the missing link, because this is new disease. So you want to find a link between the new disease to the existing drugs and the existing protein structures. So that is how drug repurposing can be done using the graph neural networks. So with this simple analogy, people have worked out, have listed out many drugs during 2020 before the vaccination happened, and some of them really worked out very, very well compared to the conventional artificial neural networks suggestions. So with this, I'll end, or I will go to the final topic, which are the future directions and challenges. So, graph neural networks are representation learning architectures, I told you. But if you go back, what happened? Graphs are encoding only pairwise relationship. So, what happened? What is the real challenge there? So, go back to your conventional example where I told you you have a friendship network data in a class of 100 students. You only have the pairwise relation, like A and B are connected and B and C are connected. It might be the case that A, B, C are well connected. Like you have a higher order data or a higher order structures, like all the three people can be friends together, right? In a class, we can always form a groups of 5 or 6 students. So, but graphs, they don't capture such relations. So they only capture the pairwise relations. But how do you capture that higher order relations is through something called hypergraphs and simplicial complex. People are really looking into these models from last 1 year. And I have some of the papers. If you are interested, really interested, and want to discuss, you can always mail me out, or you can read my papers from the Google Scholar. And you do higher order, you encode the higher order relation and develop all the network learning architectures like graph neural networks for with higher order data. Then the very next challenge, future direction people are really working out is explainable machine learning. What does that mean? So go back to the tumor detection example, or arrhythmia example. So there I showed the model n number of examples with tumor and without tumor, with arrhythmia and without arrhythmia. So whenever the new example comes, model might be able to uh, extract the features very nicely, but it will not tell me. It gives me that a solution saying that this particular individual has a tumor, or this particular individual has a arrhythmia. But it is not telling us, or it's not giving justifiable interpretable insights of what is happening, like what is causing the tumor, and what is which part of the MRI image is responsible and responsible for detecting the tumor. So people are just working out hard to get it into making the ML models more interpretable. So that is one really interesting research direction, because if you talk about healthcare applications, I feel that they are more sensitive. So whenever I say that it's tumor, you should tell me with 100% accuracy, and you should tell me the reasons behind that. You should not just say that misclassifications are not allowed within healthcare applications. So that's two very new directions people are really working out from last 2 years or 3 years. But these are really good directions that will scope or this change the landscape of AI literature for next 4 years or 5 years. So then what are the challenges? The main challenge I can see was data security and privacy. And people are really mitigating those challenges through what they do is they don't take the real world data right now. They have the real world data, but they will generate a synthetic model that mimics the real world data. So data generation models like generative AI with for synthetic data generation is really catching attention these days. So such that they mimic the real world data. So I have real world data, I'll keep it, I don't make it public, and I'll just mimic the real world data using generative AI models. So these are the two future directions and the challenges I have currently in my mind. With this, I'll end my talk. If you have any queries or questions, you are feel free to mail me. So thank you everyone for the attention. So goodbye.